Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for today is January 1, 2024. It's New Year, guys. Okay, I'll be having a discussion for tonight. It's a long video format. It's not so long. I just want to emphasize the importance of the so-called study of conic sections and the concept of the so-called completing squares. Okay, let's proceed. We got a problem here. I would like to place this one on the shorts videos, but I want to explain the concept by using a long video. So I'll be discussing a long video. It's not so long. Okay, let's proceed. We are given the problem. We are given a quadratic equation that contains x and y, and this should be equal to 0. The given quadratic equation is quadratic equation involving x and y. That will be an x square plus y square minus 2x plus 4y minus 20, and this should be equal to 0. The problem is just asking what type of conic figure is this. Will it be a parabola, maybe? Hyperbola? Okay, ellipse? Or a circle? If we try to bring out the what you call this standard form of conic sections, it is something like this. We got the equation x minus h quantity square plus y minus k quantity square, and this should be equal to 1, and this will be with an a square here, and this is a b square here. If the operation here is plus, this should fall under ellipse. Okay? And there's another equation here, x minus h quantity square plus y minus k quantity square, still equal to 1. There is an a square here, and there is a b square here. Okay? In here, the value of a is not equal to b. It should be an ellipse. But under the second condition, this is still a plus, right? This will become a circle, okay? If the value of a is equal to b, and this should be equal to the radius. So in here, it will come out that if this will be equal to r square, and this will become r square, what will come out will be an x minus h quantity square plus y minus k quantity square. Okay, this is r square, so this will become r square, and this should become a circle. So let's try to, what you call this, manipulate the resulting equation if the resulting sign will be a plus. So the answer here, it could either be an ellipse or it could be a circle, but it depends. Okay? Let's try to see if the sign of the term separating the x minus h and y minus k is a plus. If it's a plus, it's either an ellipse or it could be a circle. It depends on the value of a. If a is equal to b and equal to radius, it will come out to be a circle. If they are not equal, okay, it will be an ellipse. Okay, let's try to bring out the solution. So, the purpose of manipulating this one is we would like to go to this form here. So, I will be rewriting this one, x squared. I will now combine the x terms minus 2x plus y squared plus 4y Then I will transpose this to the right, and they should be equal to 20. So we are going to this format, okay? So to go to this format, we must have to complete the square. We must have to apply our knowledge of the so-called completing squares, or converting a quadratic equation to a perfect binomial. So on the first one, x squared minus 2x, for this one to become a perfect binomial, you must have to add up a certain constant here for it to become a perfect binomial. And so with the y squared and 4y. And to do that, it will be something like this. We will just take the coefficient of the x term, the coefficient. We will take 1/2 of that. Then we'll try to square it. Okay? Upon squaring, what will come out? That should be the one to be added to this to become a perfect binomial. So for x squared minus 2x, 1/2 of minus 2 will be, this will become a minus 1 quantity square, it is plus 1. So we in here, for this one to become a perfect binomial, we add a plus 1 over here. It is this. For the square term, or the y square term, so we are sure that the sign separating this first binomial and second binomial is a plus. So the answer here could either be an ellipse or a circle, right? If we try to make this one, convert this one to become a perfect binomial, we will take 1/2 of the coefficient of y. Coefficient of y is 4. And 1/2 of 4 is actually 2. And 2 squared is actually plus 4. So meaning to say, for this one to become a perfect binomial, okay, to follow this form here, we add up a plus 4 over here. Is it plus 4? Yeah, plus 4. Okay. We arrive at this one by using this solution here. And we arrive at plus 4 by using this one. That's actually the way on how to complete a square for it to become a perfect binomial. Okay, so rewriting this one, it's x squared minus 2x. As per our computation, we need to put a plus 1 here. For the second one, it's y squared plus 4y. And for this one to become a perfect binomial, we add a plus 4 over here. Okay, and this should be equal to, we add a plus 1 on the left hand side and we add a plus 4. So for the equation to be balanced, we add a plus 4 also on the right hand side and a plus 1. Okay, actually we add a plus 5 on the left and we add a plus 5 on the right. So we don't change the value of the equation. After adding plus 1 and plus 4, this will now be factorable to the quantity x minus 1 quantity square. It's now a perfect binomial. Binomial is actually an equation that contains two terms, right? This is now factorable to x minus 1 quantity square. For this one, y squared plus 4y plus 4, this is now factorable to a perfect binomial also, a y plus 2 quantity square. And this should be equal to, the right hand side will be 20 plus 4 plus 5, that will be 25. Or let's try to check. If we try to expand this one, the first term will be x squared. The middle term will be negative 1 times 2, or negative 2x. And the pure constant term will be the square of negative 1 is plus 1. So this expansion is now factorable to this binomial here. For the other one, y plus 2 quantity square, let's try to check if we try to expand this, it is really this one. The square of y will be y squared, the middle term will be 2y times 2, that will be 4y, and the last part will be the square of 2, which is 4. So meaning to say this expansion is equivalent to the perfect binomial y plus 2 quantity square, and this should be equal to. For the right hand side, we could write this one as simply 5 squared. Okay? So later on, it will now be something like this, x minus 1 quantity square plus the operation here, separating these two binomial is a plus. y plus 2 quantity square, and this should be equal to 5 square, and it falls under this, right? So the given quadratic equation which contains x and y is a circle. The center, the location of the center is actually at the location 1 and minus 2, right? And the radius is equal to 5 units. Okay, that's it, guys. That's the way how to, what do you call this, convert an expanded form to the so-called standard equation for us to determine if a given quadratic equation involving x and y without the xy term, if it is really a hyperbola, parabola, okay, ellipse, or a circle. But for this one here, we got only two choices. It could either be an ellipse or it could be a circle. And what comes out is this form here, so it should be circle. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes. So for those of you who would like to subscribe to my channel is at youtube.com/Prof. David J. De Los Reyes. If you want to learn something regarding mathematics, just watch my channel. This is Professor David J. De Los Reyes. If you want to share it, please click share. Okay, good evening from Los Angeles.